So Ed Lank is a computer science professor here in the Cheriton School of Computer Science. His field of research is called HCI. Does anyone know what HCI stands for? Anyone know what HCI stands for? Yes, way back there. Human-computer interaction. This is, I think, is another thing that will completely change in the next 15 years. So Ed likes sailing and he likes Porsches, but he doesn't have time for either because he has 2 boys under the age of 3 and I have 3 kids, so 2 girls. You have 2 girls now too? He has 2 girls under the age of 3 and he's going to talk to us about human-computer interaction. Ed Lank.
Okay, so one of the things we're going to do before I start to talk is I'm going to get you all to pair up, and there's a set of volunteers that are going to go around, and they're going to hand out smartphones to each pair. Now, that's your smartphone. So don't get too excited. But you can keep it. Okay, so there's volunteers going around and they're going to be handing you each a smartphone. Each pair is going to get a smartphone. And you're also going to look inside your folder and you'll find a package of index cards that look like this. So I just ask you to get those out and let me know when everyone's actually got their smartphones. The other thing that I'd ask you to do is just be careful when you're handling your smartphone. So one of the organizers told me that you have signed a release against injury, so that's good, but we don't want you getting splinters from the block of wood that you're using, so just handle it with care. If anyone gets a splinter and is dripping blood, then talk to Heather and she'll be able to hook you up with a bandage. But they're not really that dangerous, I don't think, so it should be okay. So we're going to be using these a little bit later in the design exercise. We're going to be doing a type of design exercise called low-fidelity prototyping. It's a really common design exercise. People do it in industry. It's also something that I teach in my undergraduate courses here. So the exercise that I'm going to be getting you to do today a little bit later in this talk is actually something that I teach to undergrads here as well. So it's basically your first introduction, I guess, to a university class and an in-class exercise in a university class. Now, before I start, and not counting the block of wood that I gave you, how many of you have smartphones with you today? Can you stand up? Just stand up. Don't be scared. I'm not going to ask you to move. Okay, that's great. You can sit down now. Perfect. So what this exercise is going to be is it's going to be an exercise in designing an app for your smartphone. It's actually going to be about how people go out and design apps for smartphones. Before I get into this exercise, I thought I'd try to tell you a little bit about why software design is difficult. And what makes it so difficult now for people to design software. You'd think that you just had an idea in your head, you go out and you build it and you're going to make lots of money from it, but that just doesn't seem to be the case right now. It's actually quite difficult to come up with a design for a piece of software that people actually want to give you money for creating. So, not that long ago at Waterloo, this was what was known as the computer room. Some of your teachers actually probably remember this computer room. It was called the Red Room, and it was over in math. And this was the computer that they had at Waterloo. And what people used to do is they actually used to come along the corridors up here and look down in the window to see the computer. We used to have about 10,000 high school students come to Waterloo every year just to look at the computer, because they'd never seen a computer before. And this wasn't really that long ago. You know, you're talking 25 years ago. A lot of people would come to Waterloo to actually work with these computers right here. Now, a lot's changed in that time. And just thinking about some of the things that have changed, there's three things that I want to point out to you. One is data's changed. Does anyone here have a Gmail account? Just stick up your hand if you've got a Gmail account. Okay. For all you people that have a Gmail account, you would be terrified to realize how much Google, the corporation, knows about you. They read all of your email. They store it on their servers. They use it to tailor advertising to you. Basically, what Google's doing is they're creating this huge profile of you from the data that you provide online. They know who you're talking to, who your friends are. They know largely what you're going to do at any given time simply because you use your email so frequently. And once you log into your email, they actually also track all of the searches that you do on Google Search. So they're capturing all of this information about you and building a profile of you, and they're trying to design services that are then tailored to you. The other thing that's changed is connectivity. Computers, like the computer that were in the room, were largely the computer, and they didn't necessarily talk to other computers. Now we've got interconnected computers, and you can do, a lot of communication on them. You can shop on them. And the other thing that's changed is really the form factor of computers. So you have computers that are in every form, from tablets to laptops to smartphones. And a bunch of you here have smartphones with you today, actually. And alongside this sort of reduction in size, there's also this huge increase in power. If you think about the computer that filled the room at Waterloo, and you compare it to the smartphone that I have in my pocket right now, this smartphone right here beats this computer hands down. It's actually 1,000 times faster than the computer that filled the room. It's got 1,000 times more memory than the computer that was inside the room, and it's got about 2,000 times more storage on it. So on my computer in my pocket, I can have a couple of dozen TV shows stored. On this computer right here, they couldn't even store one TV show in the resolution that I can store a TV show on my handheld computer right now. So just to sort of drive home the point, and link this to why building software or designing software is really difficult right now. Once upon a time, not really that long ago, computers filled a room. They were incredibly expensive. They were used to solve problems that were virtually impossible to solve any other way. So they were so expensive and so valuable that you couldn't do something trivial like look up, what movies are playing locally on a computer. You couldn't use it to balance your, your books for your household or any of the, other things that we use computers for. And they were used by experts, this middle point right here. I'm sorry, I can only point to one slide at a time. But this last point right here in the leftmost column, they were used by experts who understood them intimately. It's not that big a step to say that, 20, 25 years ago, everyone who was using a computer, maybe 30 years ago, everyone who was using a computer would probably be able to put that computer together. And if you think about now, that's definitely not the case. Computers are everywhere in every size. The typical car that you drive in has 50 computers inside it. They're disposable. What do you do with your old iPods? You guys have probably all had old iPods and stuff like that. Do you keep them and cherish them and stick them in a picture on your wall? Yes? Some of you do? You're not normal if you do that. Normal people throw them away. They get something that's newer and more impressive. They can be used to solve every problem, from the important to the trivial, and they're used by people who know very little about how they work. If you think about my smartphone that I have in my pocket right here, it would be pretty rare for someone to actually take their smartphone and pull it apart like this to see how it works. Has anyone here actually pulled their smartphone apart to this level to see how it works? So a couple of you have. That's great. There's a lot more people than that have smartphones in the room. And I can tell you things about this smartphone because I'm not a normal person. One of the things I can tell you about this smartphone is if you blow up this chip right here on the bottom row, right here sort of second from the right on the bottom row, I can tell you that this is the CPU, this is the internal storage, this is the graphics processor right here, this green thing, and this blue thing over here is actually the audio codec on that motherboard. So I can tell you that, but I'm not normal. Normal people don't care about this. They want the phone to look pretty so they can carry it around and flash it for their friends. And they want it to work when they push the button and turn it on. And that's all they want to know about computers. If you think about that point right there, the fact that people don't want to know about computers and they don't care how computers work, it actually makes building software really, really difficult. For a computer scientist, it's kind of like talking to a child. You know, you guys saw a 2-year-old solving a Rubik's Cube or a baby solving a Rubik's Cube. It's kind of the same thing. What you're doing as a computer scientist is you're trying to communicate with someone who's got much, much, much less knowledge than you do of how the computers work. And what that does is it makes it very, very difficult to design and build software that people are actually going to be able to use. Now, what I'm going to talk about here, and the exercise I'm going to get you to do, is I'm going to get you to design a smartphone app. And it doesn't really matter what kind of smartphone you've got, because if you think about smartphones, they're all kind of the same. Yes, I know that, you know, the iPhone probably looks a little bit nicer than some of the Android phones out there. Maybe you think they're more beautiful. Maybe you think that the iPhone's easier to use. Maybe you think that people who use iPhones are just sort of, you know, like running after trends. They just want something that's cool and hip, and they're not real people, and real people go with, you know, different types of smartphones. But the point is that the design exercises on both these phones are virtually exactly the same. In order to describe how we go about designing apps for smartphones, though, I'm going to sort of step back to a little bit higher level, and I'm going to talk to you about the design process for building software in general. And this right here, I hope you guys can all see this fairly well. This right here is basically a step-by-step process that we teach in our undergraduate curriculum here for designing software in general. And so the first thing that you do when you're designing software is you try to figure out some unmet need that people have. Essentially what you're trying to do is you're trying to solve a problem in a way that no one else has solved that problem. And if you can do that, then you've got a shot at providing people with something that's really valuable. The second thing, so just as a quick example of that, I have an addiction. Most people who know me well know about this addiction. I'm addicted to coffee. And so one of the things that I could do with my smartphone is I could pull out the web browser, I could go to Tim Hortons' web page, I could click on the store locator, I could enter a search radius in and my current address, I could push submit, and it would helpfully give me back the closest Tim Hortons to where I am right now. But somewhere about 3/4 of a step into that process, when I'm trying to navigate around the website on a screen that's, you know, tiny and cramped, when I'm trying to navigate around the website, I'd get really frustrated and I'd probably give up. And because it's Tim Hortons, I'd basically turn 360 degrees and I'd probably see one somewhere, right? But one of the people who designs apps for smartphones figured out that there's probably an easier way to do this on the smartphone, and they built an app called the Timmy Me app. And all I have to do is click on Timmy Me, and it says, can I use your current location? And I say, okay, and it gives me the 10 closest Tim Hortons to me immediately. And so there's an example of an unmet need. Essentially, although I could do it, it was really difficult to do it. I wanted a simple way to find my coffee. I'm an addict. I'm shaking. I want the coffee right now. And what I could do is I could just press a button and get the coffee. And so as part of this process, they envisioned a new way for me to accomplish this goal. They said, why does he need to enter all this information into a website? The cell phone has a GPS chip on it. The cell phone can figure out where it is. Let's just get the cell phone to, transmit its current location and the request for Tim Hortons stores, and he'll be able to do all this in one step. They architected the overall interactions of the software. They said he clicks on the first screen, he clicks on OK to allow locations, then he gets a list of Tim Hortons stores. If he clicks on a Tim Hortons store, then he's going to get a map to that Tim Hortons store so we can see where he goes. So they essentially architect the overall interactions of the software. Then they spend a whole bunch of time refining the designs of the application's interface. No, that looks ugly. It's difficult for someone to see how to press the button there. It's difficult for someone to figure out what they're supposed to do on this screen. So they basically go back and forth refining the interface to the software until they've actually got something that hopefully a normal human being can actually use. Then they build the application and deliver it to end users, and finally they collect oodles of money and retire by age 19, which is, everyone's goal, I guess. I missed by a little bit. So the important point here, and one of the interesting things I think about this diagram right here, is if you think about this diagram, there are a lot of steps before you actually get to the part about building the software for the system. And if there's one message that I could leave with you about computer science in general, it's that a lot of what we're doing in computer science is actually doing things that you would do up here before you actually program. And this is true of me in my field of HCI, but it's also true of Anna and her field in combinatorics and artificial intelligence. Because basically what she's trying to do is to come up with new algorithms before people actually go and program those algorithms, so that you know what you're going to do before you start down here. You don't want to just stumble around down here. And so most of computer science is up here trying to figure out what you should do before you go and build an actual application. So it's the part that goes into, it's all the things that you do before you actually program is really what computer science is all about. Now, the exercise that we're going to do today on smartphones is actually going to be this exercise right here. We're going to create and refine the designs of a smartphone interface. Okay, so this is the part that we're going to do right down here. So I'm going to give you some guidance in terms of things that need to be done up here. I'm basically going to not walk you through, but I'm basically going to assume some of these steps are complete right here. And what we're going to do is we're going to do this step right here with the tools that I've given you in order to do the exercise. So your wooden block smartphone and your cue cards. Now, in order to do this, what we're going to do is we're going to use prototypes. If I say the word prototypes, does everyone here understand what that word means? Yeah? We sort of have a good understanding, I think, of the word prototypes. In computer science, we usually talk about prototypes at 3 different levels, okay? So at the highest level, or at the most refined level, we've got these fully functional prototypes. This is actually a picture right here of a prototype of the iPhone 4. You guys all may remember a news story a year and a half or so ago where some developer for Apple lost their iPhone 4 prototype in a restaurant in California somewhere. I don't know if you remember that story or not, but essentially what happened is Apple had built these fully functional prototypes, had given them to their developers, and had gotten their developers to use them for a period of time so they could actually figure out what worked and what didn't work in terms of the software. That's actually a process in computer science that we call dog fooding. So the idea is you eat what you produce. You dog food the software before you actually go about using it. Another type of prototype that we talk about quite commonly are Wizard of Oz prototypes. Just a show of hands, is there anyone here who hasn't seen the movie The Wizard of Oz? Okay. That happens, it's old. It hasn't been in theaters for a while. Spoiler alert if you haven't seen it. If you really want to see it, if you're longing to rent it, just plug your ears right now. The story of the Wizard of Oz. Okay? In 20 seconds. Time me. There's a girl, she gets grabbed by a tornado, sucked into a magical land where she follows a yellow brick road to a wizard and finally gets home. That's the story of the Wizard of Oz. The important point about this story is the nature of the wizard. So if you've seen the Wizard of Oz, you know that the wizard is this huge sort of, for the time that the movie was made, something that looks really impressive in terms of a contraption. It looked really powerful and awe-inspiring. And then the girl's little dog runs up and pulls the curtain back, and there's this guy behind the curtain moving his arms and speaking into a microphone. That's what a Wizard of Oz prototype is. A Wizard of Oz prototype is a prototype where you actually build the screen right here for a software system, but then in order to put information on that screen, you've got something called a wizard's interface right here. And the wizard sits there and watches the other user interact with the software, and when they do something, they push a button on their interface, and something new appears on this screen. And so the idea is it's a lot easier to build than something like this that's fully functional. It's a lot easier to build than that, but it still gives you the feeling of using the software. So you can actually watch people use, or the system, so you can actually watch people use the device and interact with the device and learn something about what you've done wrong without spending thousands and thousands of dollars building a fully functional prototype. So that's the purpose of a Wizard of Oz prototype. The third type of prototype that we talk about fairly commonly are low-fidelity prototypes. And what low-fidelity prototypes are, different fields in computer science use different names. In HCI, we talk about low-fidelity prototypes. In software engineering, people frequently talk about wireframes and things like that. But the idea is they're prototypes that are made out of common objects, things like paper and cardboard and wooden blocks. And you actually build these prototypes and get people to play with these prototypes. And when you do that, you can, at least at the outset, without having to do any programming at all, eliminate a whole bunch of bad ideas that you might have. So you get rid of all these bad ideas, and once you've gotten rid of the bad ideas, hopefully there's a couple of good ideas in there that you can actually refine and develop. And so that was the purpose of giving you guys all the wooden blocks today, is to give you a set of low-fidelity prototypes. Now here are some examples of low-fidelity prototypes, just to point out to you that they don't all need to be paper screenshots of a software system. So here's a low-fidelity prototype of some sort of desktop phone system. This is a low-fidelity prototype of a typical computer application. It's actually an application to browse comics. You may be able to see the comics up here. If you can't see the comics, don't worry about it. That's not really important. This right down here is a low-fidelity prototype. I actually looked at what this was. And I can't remember what it was, and I can't read it anymore. But this is a I know what it is. This is a low-fidelity prototype of an e-voting machine. So an electronic voting machine that they're trying to use in elections and things like that. This right here is a low-fidelity prototype of a medical device. It's got a couple of pipe cleaners, a couple of round pieces of cardboard on it. And these are two instances, these two snake-like things here, are two instances of a low-fidelity prototype for an athlete's training system. And I have no idea what this low-fidelity prototype does. I just found this example of a low-fidelity prototype in a textbook, and I thought it was actually a good one because it shows you sort of the fully functional prototype that you've got. And people can actually play with this prototype. And you can see whether or not it makes sense to the end user before you actually go and spend a lot of money building this special purpose device, and you find out that no one actually wants to buy it. How many of you here have heard of the Palm Pilot? Just a few of you? So if you ask, even your parents about the Palm Pilot, they will definitely have heard of it. The Palm Pilot was probably the first commercially successful handheld computer. Okay? the first highly commercially successful. There were other handheld computers. Apple produced one in the 1980s called the Newton that no one bought. But the Palm Pilot was the first one that people bought in really, really large numbers. And the founder of Palm Corporation was a guy named Jeff Hawkins. Not Jeff Raskin, he was the founder of Apple. Jeff Hawkins was the founder of the company that built the Palm Pilot. And what Jeff Hawkins did is he actually walked around with a block of wood in his pocket. He says for a week. Some people who know him say for months. And when he ran into someone who wanted to talk to him, he'd pull the block of wood out and he'd pretend to use the block of wood for things like scheduling a meeting or for a to-do list. And the reason that he did this is because he had no idea what a handheld computer that you carry around in your pocket should do. It seems obvious to us now, but after Apple Newton failing miserably, you know, you don't want to make a mistake again. Failing costs you a lot of money in business, and so he wanted to actually figure out what he should do. And if any of you actually have the chance to use an old Palm Pilot, it's kind of a cool thing to use. There's this special alphabet called graffiti that you use to write on it. And it's got a very, very simple interface that just does a few things well, like scheduling and to-do lists. Very, very, very simple, very, very compact interface. But it's sort of a cool thing. And it's a really successful example of low-fidelity prototyping. It's not a big stretch to say that because of the work that Jeff Hawkins did, companies like Apple were able to build things like the iPhone much later because he figured out what these devices should do. And this is actually a picture of a slightly more refined version of the Palm Pilot that Jeff Hawkins has posted on the web from his archives. So this is a prototype that Palm Corporation actually built of the Palm Pilot so that they could see how it would look and how people would interact with it right here. And you used to enter all your text down here using a stylus. You just draw these special shapes, a special graffiti alphabet down here, and that's the way it would recognize everything. So that's essentially an example of low-fidelity prototyping. So low-fidelity prototyping has a big history in terms of the design of smartphones. The other thing, and the last thing I'll say about low-fidelity prototyping, is it's not just something that we do in computer science. This is BMW's design process. I've gotten older. I'm not really into Porsches now. I like BMWs more. But so you've got artists and designers who sit down and they do these sketches on paper of cars. This is actually the truth. You can go to BMW's website and you can see their design process for these cars right now. So the artists sketch these pictures and then they paint these pictures of the cars. And that gives you an idea of what the car is going to look like. But in order to get a feel for what the car looks like when it's actually built in full size, they actually take black masking tape and they draw the car on the wall. So they draw the car in life size on the wall. This is a guy doing tape drawing on the wall. BMW actually pays expert artists in tape drawing to draw cars, concept cars on the wall so that people can step back and get an overall sense of them. And this right here is the same car built in modeling clay. And they do all of this before they actually build the body of the car. And it's obvious why they do this. Like, think about it. Let's say you say, this kind of sucks as a 4-door car. I'd like to make it into a 5-door car. I'd like to make it into a 3-door hatchback. With modeling clay, that's easy. Delete this handle right here, move this one back a little bit, change the line, and all of a sudden you've got a 3-door hatchback for a car. Say you say, I hate this as a hatchback, I want to make it into a sedan. Well, that's easy to do as well. You just lop the top of the window off at the back of the car right here, and you've got a sedan. And it's a lot cheaper than getting a machine to remanufacture the whole body of the car. So low-fidelity prototyping is something that you will do if you go into any engineering or computing field. It's something that you'll see everywhere in the real world because it costs a lot of money to produce a final product. It's much, much cheaper to build things on the cheap, essentially. Okay. I'm coming down with a little bit of a cold, so I'm just resting my voice right now. Okay, so we're going to do a design exercise. And the design exercise sounds pretty boring. I'm going to get you to build an email app. Everyone used email? No? You'll figure it out. It's pretty easy. But there's a twist. There's a twist. There's always a twist. You can't use the screen of the smartphone for input. No screen. You also can't use voice for input. No voice. You can't talk to your phone. You can't touch the screen of your phone. What are you going to do? Hold it to your head and think at it. No, that doesn't work. Yes? Say that again? Yep. So, you're going to build an email app for a smartphone. You can't use the screen, and you can't use voice. Now, a lot of people ask me when I give them this exercise, why can't I use the screen of the smartphone for input? What are you trying to do to me? This is stupid. It's all right, you're allowed to feel like I'm stupid. If you're in my class and you feel like I'm stupid, I can give you a test and then we'll talk about, how well you're doing and how well I'm doing. But the question is, why can't you do this? Well, there's times when you can't use the screen of a smartphone. Has anyone tried to use the screen of their smartphone wearing gloves? Does it work? No, it doesn't. Unless, of course, you buy special gloves. I think they're available for $175 from Apple that have conducting tips in the fingers that allow you to interact with the phone while you're wearing gloves. Normal people don't use their smartphones while wearing gloves or mittens. So if you're a mitten user, it doesn't help. The other thing is, sometimes you've got stuff in your hand. And if you've got stuff in your hand, yeah, you can contort your thumb in weird ways so that you can use the screen of your phone. But honestly, that's kind of awkward. It would be much better to develop sort of a better way to do something like that. Or you may just be really thirsty and you grabbed a big gulp at the 7-Eleven and you're walking down with it and you don't necessarily want to be distracted by, trying to use your finger on the smartphone right here. The other thing that people often ask me, and something someone mentioned, is why not use voice recognition technology? Apple's come out with this really cool thing called Siri, and it'll just understand everything that I actually tell my smartphone to do. First of all, if you actually believe that, you're what I like to call gullible. Think about doing a Google search. You type in a Google query, and the first thing that comes up is always what you want, right? No. You look at it and you say, well, that wasn't exactly what I want. Let me try a new query. And you try a new query, and then you say, well, that's closer. Let me look at this link right here. Oh, they're using those terms to describe what I'm trying to search for. Let me type those into Google, and maybe now I'll get what I want. The problem with voice recognition technology is, first of all, it's hard. It's hard to figure out what you mean. Even if you recognize all the words, it's not like when you type in the search query in Google, Google says, I don't understand those words. Well, maybe it does if you've got, really creative spelling. But in general, what happens is Google understands all the words. It just can't give you the information that you want because it doesn't understand what you meant. And this problem exists in voice recognition in exactly the same way that it exists in typing in a search query. The other thing about it is, I'm a geek. I teach in the computer science department at Waterloo for, goodness sake. And I think it's weird to walk down the street and talk to my cell phone and say, sit, stay, no, move. It's just not something that I think I want to do. I'd much rather do something else in terms of input. So no on-screen input and no voice input. What you can do with your cell phone is you could use what's called motion gestures. So Matt, I'm going to get you to give a demo in a second. So motion gestures are movements of the smartphone itself. Now you guys all know that you can take your smartphone and you can twist it on its side and it changes its orientation, right? Everyone aware of that? Yeah. Okay. That's because there are a set of accelerometers in the phone. Let me just bring this up right here. So Matt's at the back of the room right there. Matt, wave your smartphone in the air. There's Matt waving his smartphone. These are the readings from the accelerometer in Matt's smartphone right here on my computer. Matt, walk down the stairs. Oh, he threw it up in the air. That's cheating, Matt. So one of the things that you'll notice as Matt is walking along is you've got these signals right here. Walk harder, Matt. So you can see him bounce up and down right here. These are actually the readings. Run, Forrest, run. These are actually the readings from the accelerometers in Matt's smartphone right here. And so you can see that you can actually get a lot of information from this. You can figure out whether Matt is walking or running. If Matt flips his smartphone over, you can see that this line right here changed from actually minus 9.8 to plus 9.8 right here. Why was it minus 9.8? Because gravity was making the smartphone accelerate down toward the ground. When he flipped it over, the accelerometer twisted around the other way, and it recognized the fact that gravity was pushing on the back of the phone rather than the front of the phone. So there's actually quite a lot of information. Matt, take your phone and bang on the back of it. So you can see right here, this is Matt banging on the back of his phone right here, and you can see this signal. Take your phone and bang it on the table as hard as you can. It's my phone. You can do whatever you want to it. And so you've actually got right there the signal that you've got from the accelerometer. Matt, hold your phone sideways up in the air like this, just on a straight vertical like this. So you can see right there at the top, because Matt's holding it vertically like this, the long way like this, you've actually got gravity pushing down on the x-axis on the phone right now, the width of the screen. So the phone can figure out a lot just from the accelerometers in the phone. You can flip it over. You can shake it. You can flick it. You can bang it on something. You can scratch on the back of it. All of these things are things that the accelerometers can actually sense on the phones. Do it again, do it again. Are you trying to crash my laptop up here? That's all right. Matt built the software, so if you crash the software, it's on him. He's one of my grad students. Poor guy, I made him work for this presentation. So if he crashes the software, it's all his fault. We'll just see how brave he is in terms of trying to make it crash. So that's the accelerometers on the smartphone. You're going to use the block of wood to design these interactions, and I'm going to give you a few minutes to do it in a second. Now the other thing that you see in front of you is you actually see these cue cards right here. Now, commonly in a design exercise, what you do with these cue cards is you actually use them to draw the screens on the smartphone, but I'm not actually going to get you to draw. Instead, what you can do with these cue cards is you can use them to provide output from the phone for each motion gesture that someone performs. So someone flips over the phone, what might the phone do to tell them that it sensed them flipping over the phone? Well, maybe what it does is it clicks like this. Can people hear that click? Can you hear that click in the microphone? So maybe it clicks like this. Maybe if they shake the phone, what it does is it creates a feedback sound that sounds something like this, or a vibration that sounds something like this. You hear that? So basically a tearing sound. Maybe if you shake the phone, what it does is it vibrates in some weird way like this. And so you can actually use the cue cards like this. You've got 10 cue cards. Don't tear for everything. You'll run out of cue cards. But you've got 10 cue cards each, and you can actually use that to provide feedback. One of the reasons that feedback is so important in this exercise, is because if you think about using the screen of your smartphone, the minute you touch the screen, something happens on the screen. And so you know that you've successfully made contact with the screen and something's happened. Imagine you reach the end of a list of items and you're using this right flick in order to move through the list of items. Just as an example, you don't need to use that gesture. You can come up with something better. I'm not creative, but imagine you're using this right flick. You're at the end of a list of items, say email messages, and you don't know that you're there. You do a right flick, and nothing happens on your phone's screen. What you think is that you didn't do the right flick right. So you try it again, and it still fails. So you try it again. And then you get really, really angry, and you're standing at a bus stop in the middle of minus 20 degrees Celsius Waterloo weather, or Markham weather, and you pull your glove off, you freeze your fingers, and you swipe on the smartphone to go next, and you say, oh, damn, I'm at the end of the list of items. And I had to freeze my hand in order to figure that out. So the point is that for each action that you design in your groups of two, it's very important that you have feedback for that action. So just to recap right here, you've got these two pieces right here. This is for designing the gestures that you're going to use. This is your block of wood for designing the gestures. You can twist it, you can shake it, you can flick it, you can spin it, you can do whatever you want. You can't hit someone else with it, and you can't throw it. Two simple rules. Everything else is fine. I know. I suggested that. The teachers are going, oh my God, why did he say that? And this is for output right here. Okay. 1 second. 1 second. So 1 second. Just before you start, you can design as many gestures as you want, but it's a good idea to know what those gestures are supposed to do. Right? Just standing there shaking your smartphone for a gesture is fine. What does that gesture mean is sort of an important thing to figure out. So, just some requirements for your app. Your app has to support, well, it starts in the inbox, and you need to be able to scroll forward and backward through your list of messages, and you need to be able to select a message to open it on the screen. That's all your app does. From there. Within a message view, you need to be able to scroll up and down in the message to read the message. Maybe like this, maybe like this. However you want to scroll, doesn't matter. Maybe just move the phone straight up in the air. You need to be able to move to the next message and the previous message. You need to be able to delete a message. You should be able to reply to a message, but when you reply, you're just going to send back something that says, yeah, I got your message, I'll email you in a little bit, or I got your message, I'll get back to you in a little bit. So just an acknowledgement that says, hey, I received your message. You need to be able to mark the message as unread, and you need to be able to go back to the inbox. So those are the gestures that you need to design. What time is it right now? What's that? 11:50. 11:50? You have 5 minutes to do that. Okay, so That was a quick little exercise for how people design things when they're actually going about brainstorming to try to produce new interactions around a device. So if you wanted to actually use something like motion gestures, movement of the smartphone, to control an email application, this is one of the ways that you do that. So just to pick a couple of examples, for the reply here, for acknowledgement, did anyone come up with a good gesture for that? I have no idea how to do that. Yeah, what did you do? So, he waved to the person, yeah. Just flip it forward like you're passing a message back. Anyone else? Yeah. Shake it like this, twist it like this in order to reply to someone. Yeah, right there at the back. Show the gesture. You just toss it up in the air. That's not bad either, yeah. Spin it around like this. So there's a bunch of gestures, all of which you could use for replying. What about mark as on read? Yep. Show me. Flip it like this, like you're closing it. Yeah, that's a cool gesture. Yeah. Flick it backwards like this. Yeah. Turn it over like this. That's not too bad. Yeah. Just go like this. Oh, check mark. That's not too bad actually either. Yep. Show me. Okay. So, let's say you've built your app, or you've designed your app. You've got this wooden block. It doesn't do anything, but you've got this wooden block, and you've got this idea for gestures. What do you think you do with them? Well, the fact is, what you do is you'd actually get people to try them with the wooden block to see whether or not they could remember them, to see how they performed the gestures, and to see whether or not they liked the idea of the gestures. So you'd actually go out and you'd evaluate your prototype system, and the most common way to evaluate things like this, used a lot, is called a think aloud. And it's exactly what it sounds like. You get someone to use the system, and while they use the system, you tell them to tell you what they're trying to do. And so if they tell you what they're trying to do, and that turns out to be something different, then maybe your gestures aren't memorable enough. Maybe you need to redesign them so they're easier to remember. Maybe people can't remember the check mark gesture for mark as on read. When they want to do on read, they just want to flip the phone over, and that's the way they think of it, is as flipping the phone over. And so they decide to go with that gesture instead, your gesture, right? Why do you do that? Well, the point that I made earlier is that when you get to the point when you can actually design and build software, you know a lot more about computers than the people who use the computers. And so getting them to think aloud while they use systems that you've built tells you whether or not they can figure out what they're allowed to do at a certain point in time, what they're trying to do at a certain point in time, and how they're trying to do it as they go through using the system. So you give them the app, let them handle it on their own, and you only help them if they're completely lost. Once you've done that, you iterate on this process. You keep on refining your designs. You keep on building it with a block of wood. Once you've built it with a block of wood, the next thing you do is you build a piece of software, like the software that Matt built for your demo, and when you see someone do something on that software, you'd issue the command to the smartphone so that it looks like it's actually working the way it's supposed to work. So you actually issue commands back to the smartphone. You build this Wizard of Oz prototype, and you see whether or not people can actually use it and whether they like it. And once you've done that, it's probably worth your while at that point, if people actually like this, to put a whole bunch of effort into writing recognizers for these motion gestures, because you're going to need to recognize them when people do them. And that's going to take quite a bit of work to write that recognizer, but only if you know that it makes sense would you want to put all that effort into writing the recognizer for the motion gesture. Otherwise, throw it away and try to figure out something else. Maybe voice is the next great thing. And in the same way that we go around talking to our dog or our cat, we're going to talk to our smartphones in a few years. Who knows? I don't believe it, but maybe some of you believe it. Last thing I'll say. This is the end of my talk. It's also really approaching lunchtime, I think, because it's probably like 11:58 or 11:59 right now. It's 12? Okay. So, I haven't set this website up yet, but later on today, Matt's going to get me the APK file for his Android phones. We only have an Android version of this. If you have an iPhone, you're out of luck, sorry. And I'm going to post my slides, and we'll post the software, including the software that was running on my computer, on this website. So if you really want to download it and try it, you can feel free to go ahead and do that. That's it from me. The announcement you've all been waiting for is lunchtime.